Hey, chemistry kids, welcome to 6.2 about molarity. We've already been discussing solutions and stuff like that in our previous units. Solutions are liquids that have dissolved material in them, and we've seen that you can have a weak solution versus a strong solution when we're talking about concentration and rates of reaction and stuff like that. Now we're going to quantify that. How do we actually calculate how strong a solution is? This is called molarity, the concentration of a solution measured in moles per liter. The unit is molar, just like a tooth, and is abbreviated just capital letter M, where 1 molar is the equivalent of 1 mole of the solute in 1 liter of solution. So, moles divided by liters. So for example, if we were using an acid and it says it's 6 molar HCl, which we've done, we've used 6 molar hydrochloric acid before, that means for every 1 liter of the acid, there would be 6 moles of the hydrochloric compound involved. Our calculation here is really simple. Molarity equals moles divided by liters. The only tricky part is if you're not getting your data in the right units, because we're usually told grams of material instead of moles. So to determine molarity, then we have to convert things into the right units. Step 1, we're going to calculate the number of moles. If we have to do grams to moles conversion, we divide by the molar mass. And you remember, we find the molar mass by looking at the periodic table and all those numbers at the bottom of the squares and finding the sum of the numbers for that compound. Then, if we're given milliliters of solution instead of liters, we have to do that conversion. You divide the milliliters by 1,000 to convert to liters. And then finally, you take what you got, moles divided by liters, and you have your molarity. Let's see an example. If I have 30 grams of sodium chloride, table salt, dissolved in 500 mils of solution, what is the molarity going to be? Well, I have a compound, I need to know its molar mass. So step 1 would be finding the molar mass of NaCl. On the periodic table, sodium is 22.99 and chlorine is 35.45, and so together the molar mass of sodium chloride is 58.44. Now I'll divide the grams, 30 grams, divided by the molar mass, 58.44, to find how many moles I have. That's going to be 0.51 moles of NaCl. And then finally, to calculate liters, 500 mils divided by 1,000 is 0.5 liters. And now we can plug it in. The molarity is 0.51 moles divided by 0.5 liters, 1.02 molar NaCl. Remember, we're rounding everything to 2 decimal places, so don't round it off to just 1. We can also calculate it backwards. If I tell you the molarity of a solution and how much of it I need, how many grams do I need to make it? This is actually the calculation I probably do most often in labs when I'm doing my prep work for that, because I need to make the solutions and you always have to sort of back calculate how many grams to measure on the scale. So it's NaCl again, so we're still going to have the molar mass of NaCl, 22.99 plus 35.45 is 58.44 grams per mole. In this case, we're making 300 mils, so that in liters is 0.3 liters, and we're told right off the bat that it's 2.5 molar. So we're going to rearrange our molarity equation. Molarity is moles divided by liters. If we're solving it for moles, moles is the molarity times the liters. So 2.5 molar multiplied by 0.3 liters gives me 0.75 moles. Now I have to do moles to grams conversion. For that, we multiply by the molar mass. So 0.75 moles times 58.44 grams per mole, I need 43.83 grams of NaCl. I would measure on a scale, I'd measure out 300 mils of water, and then just mix them together, and I would have 300 mils of 2.5 molar solution. Alright, that's it. These are not very hard. There's a couple different steps. I'm not going to make you do a lot of math for the homework. There's just a couple of equations to handle. But overall, I don't think this is too challenging. Alright, thanks for your time. Have a great day. Bye.